Calculus 2 area between or under curves. Work on problems 5 to 10, 15 to 28. In this example, we are going to integrate the following area. However, we're going to integrate over y. Note that in this case, we can integrate over x as well because the rectangles over x have as top the same line throughout and bottom the same line throughout. But we want to practice integrating over y. And that's also possible because our rectangle is also going to have the same line as top and bottom throughout. However, note that the function is y equals x and y equals square root of x. So the first job is to switch. Instead of y equals x, we're going to say that x equals y. So that is because in order to integrate dy, all variables must be y. So this is the first step. Now, since we have y equals x, which is actually square root of x, which is x to the half, we must square both sides to eliminate this half power. And this now gives that x equals y squared. So now we have y and y squared, and that allows us to do dy. So this rectangle is dy. Therefore, the next problem we need to solve is top line minus bottom line, but we're doing dy. When we do dy, who is top line? Well, actually, if you're doing dy, rightmost equals top. So it means that on this rectangle, the rightmost line, which is this line, is the top of the rectangle. Therefore, we are going to say that the top line when doing dy is the line to the rightmost side, which is y. We just found it there. Minus leftmost line. Well, the leftmost line is going to function as the bottom of the rectangle, which is this line, which we found to be y squared. So we are in the process of doing top minus bottom equals 0, so that we find the intersection points. The intersection points for us is actually from 0 to somewhere here to find the topmost for this line. Well, we can see here that we should factor out 1y and we get 1 minus y equals 0. This allows us now to say that in order to get a 0, y is either 0. If I put a 0 here, I get a 0. Or 1 minus y is 0. Therefore, 1 equals y. It means that y equals 1. So I'm going to integrate from 0 to 1. You must apply this principle for any pair of functions. You must do all the necessary factoring, set that equals 0, and solve for the variable you want. And that gives you the limits of integration. So the limits now are from 0 to 1. And I'm integrating over y. So I want the rightmost line, which is y, minus the leftmost line, which is the bottom of the rectangle, which is y squared, and dy. And that's it. You don't want to integrate after you factor. You don't want to integrate this. This will give you a nightmare integration. You want to integrate the subtraction. This integral is going to give y squared over 2 minus y cubed over 3, going from 0 to 1. Obviously, we have the variables on both. If you plug a 0, it disappears. Therefore, all you need is to plug a 1. And this is 1/2 minus 1/3. You can put on a calculator or do LCM. LCM is 6. 2 to 6 is 3. And 3 to 6 is 2. and the answer is 1/6. Note, this is area, therefore the correct answer is 1/6 units squared. And this was an exercise in switching the variable to y in order to do dy, finding the